your school days. And this is one kind of graph where we have vertex and edge. So vertex and edge in the sense one point will be, so here you could see. So here you could see that V1, V2, V3, V4. So here there are how many vertices are there? 4 vertices are there, and edge will be this line V1 to V2, V1 to V4, V1 to V3. These all will be edges. So edges 1, 2, 3, 4. Then this cross edge, so 5, and this one, so 6. There are 6 edges over here. So first you should know what is called vertex, what is called edge. So vertices only we will be telling it as nodes. Okay. Edges can be, there is elements of E. Edges will be, can be also called as directed edges, or it is also called as arc. Also it's fine. So in this graph there are 4 vertices V1, V2, V3, V4, and the remaining all are edges, and it is an undirected graph because there is no arrow mark anywhere. You can go to both the sides. V1 to V2 and V2 to V1 also is possible. So here what is directed graph? Directed graph you can also call it as digraph, which consists of, there will be some direction. You can see here. Only you can travel from V1 to V2 but not V2 to V1. So that is what in generalized it is given that directed graph, most of the edges will be V comma D in general. V, this is V and this is W, means V comma W will not be equal to W comma V. Okay, not equal to. So for directed edge, always with one will be source and another one will be destination. That is what called as tail and head, or source and destination, and it is represented in terms of arrow marks. So V1, V2 is not equal to V2, V1. Similarly, V2, V3 is not equal to V3, V2 because only one side directed. But undirected graph is the opposite way. Opposite way in the sense both the sides is possible. This is same, but in previous thing you could see that it is not same. So here there is no arrow mark between any edges. V1 to V2 no arrow mark, V2 to V1. So both are equal. I can travel both the sides. Then weighted graph. Weighted graph means you assign some weights. If there is no weight, I'll tell you we will be taking it as 0 or infinity based upon how it is. But if there is a weight, you should take the weight. V1 to V2 is 1, but V2 to V1 is not 1. Okay, V1 to V2 you can tell it as is equal to 1. But V2 to V1 is not 1. If this both are applicable for this graph. Applicable for this graph. Okay, it can be. But in this graph, see, both V1 and V2 is 1 and V2 to V1 also 1. So this is a directed graph, this is an undirected graph with weights. Weights are assigned, or otherwise some problem they'll be giving it as cost. Okay. And complete graph. Complete graph means all the vertices are connected to one another. Where there is edge between every pair of vertices. Every pair of vertices. That is, you can see there is no arrow mark, nothing. If there is arrow mark, then you have to give on both sides. V1 to V2, then V2 to V1. That all will be, also you can tell it as a complete graph. But here no arrow mark, so it is a complete graph and all have connections to one another. So a complete graph will have n into n minus 1 by 2. N means vertices. N is the number of vertices. So n into n minus 1 by 2 edges. So if your n is 4, then you can calculate with this formula. You are getting 6 edges. As I told you, 1, 2, 3, 4, 5, 6 edges. Okay. Similarly, strongly connected graph. Strongly connected graph means if there is a path from every vertex to other vertex. That is V1 to V2. V2 to, see, in this graph you could see there is no arrow mark. This is also a complete graph, and I can tell that it is strongly connected also. But in this case, it is not. This is a strongly connected, but this is not. Because why? Because we are not telling this is weakly connected. Can anyone answer? What happened? No response from your side.
Ma'am, in the strongly connected, we can go in any direction we want.
Yes, yes. But in weakly connected, we cannot travel. It is only one unidirectional. Okay, this is bidirectional, both the sides. Okay, okay. So a path. So what I can tell it as a path. Maybe for example, if I take this diagram, the path from V1 to V3. What are the paths from V1 to V3?
V1 to V2 and then to V3.
V1 to I can go to V2, then I can go to V3.
V3.
There is another one direct path also. V1 to
3.
V3. So this is what called as path. If from the source to the destination. And what is the length now? What is the length of this path?
3.
3 years. Not 3. Uh,
Two.
2.
Number
Okay.
2,
edges.
sorry.
Yeah, edges. That is number of edges. So this is 2. This is 1. Okay. This is the length of the path. That is what given here. And loop. What is a loop? Loop means from a particular to itself. So V1 to V2, V2 to V3, V3 to V1 will become a cycle. Loop will be like if it contains a vertex to itself. Okay, maybe for example, if I am giving like this is a loop. Okay, V1 to itself, V2 to itself is a loop. Loop and cycle. What is the difference between cycle? Is I'll have the path from V1 to V2, V2 to V3. Again, instead of this arrow, I'll be having one more arrow like this is a cycle. If I have an arrow like this, it will be a cycle. V1 to V2, V2 to V3, V3 to V1. It is a cycle. Okay, so that's the difference between loop and the cycle. That's what here it is. Cycle is here. Okay, and the path. Okay, that is done. Now the main thing is in degree. In degree is very degree. It's very important to find calculate the problems. In degree will be the number of edges in that is incoming. I can tell you. In degree means the edges and degree in the sense degree means the edges which is entering into it. Out degree and in degree. We tell it as 2 degrees. So when I tell you as in degree of V1 means the incoming. How many incoming to V1? When I tell it as out
1.
degree, how? Yeah,
That will
1.
be in degree, right?
Yes, that is in degree. V1 1 means in degree. And out degree of V1 will be 2. Okay. So what will be the in degree of V1 and out degree of V2? What is the in degree of V1? Not V1,
Degree of
V2.
V1 is 1.
No, V1,
V2
V1 leave it
also.
there. V2, V2.
V2 is 1 in
One.
degree.
In, yeah, in degree is 1. Out degree
2.
2.
2.
1, 2. Yes, okay. So I think you are clear. Similarly for V3,
1, 2 in degree,
3 2 out degree 1.
1.
out degree, yes, okay, correct. Okay. So this is how we have to calculate the in degree and out degree. Then a cyclic graph. See here we saw a cyclic graph where it has connections between one another. But a cyclic graph is also called as abbreviated as DAG. That means directed cyclic graph. It will not have a cycle. It will be similar to a tree. This is also called as a graph only. And there is no cycle. A, B, C. Simply, it looks like a tree itself. Okay, this is also a graph, but called it as DAG. Directed. It is a directed graph. So it is called as directed acyclic graph. Now the representation of graph is very important. How to represent a graph? A graph can be represented in two ways. One is adjacency matrix. Another one is adjacency list. Okay. So adjacency matrix. Adjacency list will be going with like linked list. It will keep on going. But normally we'll take adjacency matrix representation. So how to give the adjacency matrix representation for a directed graph? For a directed graph, you look into here. A of ij, I mean row and column. That's the name. Is equal to 1. It will be 1 if there is an edge. 0 if there is no edge. So it is very easy. You can matrix format I've done here. And V1 to V2, there is an edge. So first V1 to V1, right? So V1 to first I will write all where is this edge and remaining I'll apply that's 0. That's all. So you can follow in either way or you can go one by one. V1 to V1, there is no edge, so 0. V1 to V2, there is a edge, so 1. V1 to V3 also there is edge. But V1 to V4, no edge. So I am giving it a 0. So 0 for all which does not have edges and 1 for all which has edge. Okay. So when you do it manually, what you can do is first mark all the edges, all the matrix, keep it as 1, all the values, if there is an edge, all the values, you can, remaining all you can put it as 0 and check once whether it is right or not. This is for directed graph. But for undirected graph, then it is easy because V1 to V2 also it will be 1, V2 to V1 also it will be 1. So probably your diagonal matrix alone only you will be getting as 0 and this will be 1. V1 to V4 also 1 and
Ma'am, so the diagonal matrix will always be fixed at 0, right?
yes, diagonal matrix if there is no connection to itself. If there is no connection to itself, maybe if I have like this, then it will be 1. Okay, if there is no
Okay, ma'am.
connection, it is actually 0. So now that is for directed and undirected graph. Now this weighted graph only we will be doing it in problems, weighted graph. Now all the problems weighted graph. So here what is the thing is whatever cost is given that you have instead of giving marking, so for directed graph you give if there is no cost then you will be giving it as 1. If there is an edge, notating that there is then giving the notation that there is an edge. But when there is a weighted graph there are some weights assigned to it given. So either in a problem they will give this matrix, so you use this matrix, or else they'll give this diagram. So if you need both, you can take this from here and this from here also, it is possible. Now, why this weighted graph is, how we have to give this weighted graph? V1 to V2, there is a weight called 3. So 3 is given. Similarly, V1 to V3, it is 9. Okay, that I also I have done. And and then V2 if I take V2 to V4 alone, I am having I think V2 to V4 value is 7. 7. Okay. Now V3 to V2, I'll be giving it as 1. V3 to V2. Fine. Now V4 to
Ma'am,
V3,
so
I
what is
have
that
given
like
as,
symbol instead of
yes.
0? Why are we giving that symbol?
Yes, not symbol, that is the meaning is infinity. Infinity.
Ma'am,
Okay,
why?
infinity. I'll tell you, wait. So infinity. So all other weights I have assigned to the
And then V4 to V2 should also be infinity.
V4 to V2, yes, infinity only. V4 to V2. I've given us one. This they have got. Previously we did this, but they have not corrected this. Actually, the units were splitted by different faculties, so they have taken as an image which I couldn't edit it. But actually it should be infinity. Okay, to be done, I'll tell you all the weights you have to assign, and to itself alone will be 0. V1 to V1, V2 to V2, V3 to V3, V4 to V4 will be 0, and the remaining weights we do not know that remaining weights of other vertices or edges, so we are giving it as infinity. Why we are giving it as infinity means, see, suppose if you are going to, you cannot, this mainly this weighted graph you will be using for shortest path or finding the shortest path from one place to the other place. Okay, so when you want to find the shortest path from source you are starting, and towards the source itself you will not calculate any cost from the source to itself, so that I am marking it as 0. Okay, now if I want to travel from V1 to V2, I know the cost is 3, but if I want to travel from V1 to V4, even though there is no direct connection, but I have a route where I can go from V1 to V2 and V2 to V4. Okay, so unless I find this using my algorithm or using manually, what I using my calculation, I do not know what actually it is. So I'll give it as infinity. So if we want to travel from one place, maybe for example, from Chennai to somewhere else, from to Delhi, wherever you know, maybe in the mid, you do not know, maybe you know the direct cost from Chennai to Delhi, but in the middle, if you want to land somewhere, you do not know the cost. So what you can do is You will be having an indirect path. You may not have a direct path from Chennai to the particular place, but you will be having some indirect path where you can reach to Delhi. So at that time, what you will do, you do not know the cost, so you will be giving it as infinity only. Okay. Later, when you solve the problem, you will come to know the path from wherever infinity is there, or based upon the problem what they have asked, you can calculate the path. So unless then it will be assumed as a default thing infinity only. Understood? So this is what. So when problem comes, you'll be more clear why we are giving that infinity. So keep it in mind. But if there are weights, give the weights. 2 itself means put it as 0. Remaining all will be infinity only. Okay, infinity only for the remaining weights which are not assigned. Okay, so when problem comes, we will be more clear in it what how to do. So this is what. Now see here, adjacency list representation. Now till now what I told is adjacency matrix. Adjacency list means this will be like in a list format. This is an array. Normally you take this as an array which has a connection to the next pointer. So here 0, this is what 0, this is 1, and this is 2. I have 3 nodes 0, 1, 2. So 0. From 0 to 1 there is a link. So I have done a link. Then after that I ground it because from 0 to any other there is no link. Now again 1 to 2 there is a link. So 1 to 2 also I have given. And from 1 to 0 also there is a link. So what I will do, I can make a connection from 2 to 0. Or else you can give the 0 first and then 2 also, it is right only. Okay, either you can give 0 2 or 2 0. That is possible. Both are possible. From 1, actually from 2 there is no other, no link. So I am grounding it. Null. That is a name. Okay, this is what adjacency list. But normally we will be going into practice for adjacency matrix. This we will do in hashing. When hashing comes, this is needed in hashing actually. And similarly, now see here, there are 4 nodes. So I have created 1, 0, 1, 2, and 3. Okay, 4 nodes. So 0 to 1 and 0 to 2, 0 to 3. I have all 3. So 0 to 1 you can do, 0 to 2 you can do, 0 to 3 you can. You can give it in order itself. 0, 1, not 0, 1, 2, 3. Similarly, from 1 also I have to 0 to 2 and 3. So I can do all. Similarly, from 2 also I have to all, so you can ground. Likewise, everywhere I can give. There is no connection, you should leave any one which is not having connected to one another. So, normally hashing itself most of the time saves the memory and O of n time to determine whether there is